Compumedic's NeuroScan provides comprehensive solutions for epilepsy, beginning with EEG acquisition to EEG data analysis, through estimating the source of the epileptic activity and assistance in surgical planning. Here, we will review co-registration of MRI, CT, and PET, as well as segmentation of a cortical surface grid and voltage distribution mapping on this grid in a patient. The first step in this process is co-registration of the neuroimaging data. In this view, we see three data sets. First, we see the MRI data, then we see the CT data, which can be thresholded to reveal various features, and finally, the PET data. At this point, we focus on the structural MRI data and begin our co-registration process. We start by identifying fiducial landmarks on a recreated surface from the structural MRI. We then confirm that in cut planes of the MRI for the nasion, as well as for left and right landmarks, in this case the tragus for the left and the right ear. Once we have confirmed the location and placement for the left and right tragus, we have established a three-dimensional plane that can then be used for automated co-registration of the CT and subsequently the PET. Now we turn to the CT data. We go to the landmark interface. Again, we can easily visualize the nasion, but certainly would have more difficulty with the tragus point. We click on Auto Detect, which performs a volumetric iterative co-alignment for the MRI and the CT. We then complete a similar process with exactly the same automated co-registration for the PET data. Once this is completed, we have the ability to check that co-registration by overlaying the individual data sets onto the structural MRI. Here we can see the PET data overlaid onto the structural MRI, and we see a very nice alignment of this data in all three planes. We can also perform a similar comparison of the CT data onto the structural MRI. In this case, we threshold the data to produce a green outline of the bony structures. And again, we can see the accurate co-registration of the teeth, the vertebrae, and most importantly, the skull itself, including the openings in the skull. The co-registration of the CT onto the structural MRI is of course most critical, because ultimately what we want to do is to identify the grid as well as the strips, which can be seen in the bottom right corner of this graphic. Currently I am adjusting thresholds so we can get a better isolation of the grid and the strips. However, we can see that the staples remain, as well as some wires on the back of the head as part of the interface to the grid back to our EEG system, as well as the teeth. So what we do at this particular point is we build a mask of everything that is close to the brain itself and invert that mask so that anything that is far from the brain will be removed from our image. And once the grid and the strips have been isolated, we then turn to segmenting the cortical surface. Our ultimate goal is to have the best and most accurate representation of the cortical surface for an individual, so that when we are looking at the alignment of the grid relative to the brain, this will be able to help us in further surgical planning. We are now completing the segmentation of the cortical surface for the brain, and we will see that segmented cortical surface here shortly. And on that, we will superimpose the voxel representation of our grids and strip electrodes. We then mark each of those voxel locations with a point in space that allows us to define the entire grid. Briefly across from the beginning to the end of this to mark all 64 points in the grid. And for now, we will just focus on the grid itself. The markers that we have shown in this display can then be converted to representations of the electrodes in the grid. We can take those passive markers of electrodes and convert them to active representations of EEG activity recorded on the scalp, negative voltages to be represented in the color blue, and positive voltages to be represented as red. The cortical surface is then reintroduced, allowing us to visualize the alignment of the electrode grid with the brain surface. We now also display a small segment of EEG containing representative spike activity. At certain time points in this display, we can see a very nice alignment of the voltage distribution, the positive to negative topography that aligns very well with the anatomy of the brain. We can rotate the brain in 3 dimensions. We can adjust the geometry of the grid relative to the brain. We can align it for an optimum view of the surface of the brain. We can adjust the size. We can isolate the grid. We can show the structural image of the brain activity, and we can do cross slices through the brain. In this particular case, we have the MRI slices superimposed on our resliced 3D surface, but we can also superimpose the PET data as well. And that's shown in this configuration. That can be moved any location in the display. As well as you will notice on the structural MRI in the bottom right-hand corner, we can also see the electrodes present as we move up and down through the anatomy of the brain. Thank you for your time. At Compumedix Neuroscan, we provide the most complete solution for your epilepsy needs, from EEG acquisition to data analysis, through epilepsy source estimation to surgical planning.